Hi, this is Spirent Communication Support Services, and today I wanted to do a demonstration on how to configure a 2544 throughput test that uses asymmetric loads. In this case, the goal is to find the maximum throughput using a 2544 throughput test, but the twist here is that we'll have multiple streams, and these streams will have to have different loads. In a 2544 throughput test, if you have multiple streams, the streams would have the same load. In other words, if you had 5 streams and you were sitting at 100% throughput, then each stream would have 20% load. But in this case, what we want to do is have one stream, as we see in our test topology below, say start out at 99.9% of the load, and the other one at 0.01% of the load. And so this is what we'll try to configure in this very simple test topology. And then if you need, this is just instructional or just an example. And then if you need to scale up, you can use more ports, more streams, so on and so forth. What we'll try to do also is to use the step-based versus the binary search pattern when incrementing or decrementing the load based on the pass-fail criteria of each load. Now here are the configuration steps. It's pretty straightforward, and actually I won't really go through them or talk about them here because we'll go through them in the GUI itself. So again, what we'll do is use the Asymmetric Performance Test Wizard to accomplish this. So let's go ahead and switch to our Spirent TestCenter GUI. So here we have our Spirent TestCenter GUI, and I'm connected to ports 9.1 and 9.2, and they're running through a layer 2 switch. So first thing I'm going to do is create some device blocks. You can do this within the wizard, but let's just do it outside. Alright, they're going to use one VLAN, and the VLAN will be VLAN 20. It's a layer 2 switch, so I don't really care about the layer 3 addresses. So we'll leave that alone. Just take the defaults. And so let's go ahead and make sure that we have unique MAC addresses and we're using the right VLAN. Okay, very good. So our devices are configured. As mentioned earlier, we could use a 2544 test, but the problem is that it balances the load across all the streams that we'll be using, and we can't use that in this test. So we'll use the Asymmetric Performance Test Wizard. We'll select the throughput test and step through this. Now when you first come to this screen, what you'll see is both will say downstream. And really what you want to do is configure one side of the test, downstream side, and then the other side, the upstream side. So you just go ahead and select the ports that you want to use and then configure either designate it as a downstream or an upstream port. Right, we already have device 1 configured on port 9.1 and device 2 configured on port 9.2, so we're good there. Now we're going to configure this traffic. By default, you'll have the automatic mode, but what we want to do is do this manually. Right? Do you want to keep the auto-created stream blocks? No, because we're going to build our own. So let's go ahead and step through this, and this is just a stream block wizard. So let me center that. We're going from device 1 to device 2. I'm going to make it bidirectional. Let's call this 99.9% stream block. You can change the frame size as needed. I'll leave it at the default. Nothing to change there. Load profile, we can just leave it as the default because we'll actually configure that as we step through the wizard. Receive ports, we can leave that default because these receive ports are implicit by the ports that the device blocks are configured on. So we can leave that blank. Go ahead and finish. So we see we have two stream blocks named 99% stream block 3 and 99% stream block 4. And these are just ones going from 91 to 92 and 92 to 91. So let's go ahead and add another pair of stream blocks that represents the 0.01% load that we need on the other set of streams. So a very similar process. I'll kind of just run through this real quickly. This will be 0.01% stream blocks. Same thing, accept all of the defaults. And we don't want to overwrite the configuration because we need them both, right? So in each direction we have a 99.9% and a 0.01% stream block. So we're good. So let's go ahead and go to the next step. I'll use just 1518. Usually you have a list here, but since I've walked through this before, I've already configured it for 1518 just to use one frame size. Again, I'm using a layer 2 switch, so we'll use layer 2 learning. We'll leave everything else as defaults and go to the next step. Now this step is actually the key step here, upstream and downstream. And you notice under stream block count we have 2 and 2. So what we want to do is actually redo what the wizard has already done. So the first thing I want to do is go down here to the throughput profile and deassociate these two stream blocks from this profile. And I'll do the same thing for the downstream profile. Okay. And notice that we're in a profile allocation mode of manual, and that's what we want to do because we're going to manually configure this. So what we'll do this is change this to, rename this to 99% profile. Load profile, and make this one 0.01% load profile. Okay. Now we're going to reassociate stream blocks with this profile. So go back, and we're going to select the 99.9% stream blocks for that 99.9% load profile, and similarly we'll select the 0.01% stream blocks for the 0.01% load profile. Alright. Now the next step is to configure the loads on this. So the upper rate on this 99.9% load profile will be 99.9%. And our initial rate is, let's say, 99.9%. And we'll go ahead and use a step. So this says if we pass or fail, which when we increment or decrement the load, how much do we increment or decrement it by? We'll go ahead and go by 1%. Right, and we'll do a similar thing for the 0.01% profile. We use step. The upper limit will be 0.1%, right? 0.1 plus 99.9 will make 100%. But our initial rate will be 0.01. And our rate step will be, say, 0.02%. Okay? I'm going to use, say, a trial duration of 10 seconds so we can get through these load iterations fairly quickly. So go ahead and say finish. And what we'll do see here is that Spirent TestCenter will build this command sequence for us. And note that it is a 2540 throughput test. But by using the asymmetric performance test, we can create those asymmetric loads. Alright? Alright, so let's go ahead and I want to change our views here just a little bit. Let's bring our L1 counters to the left. And let's go ahead and pin our command sequence. Ooh, okay, let's not do that. Let's just bring it out like that. Alright, so let's go ahead and run this. And I may pause the recording here and there just so that, for the sake of time. Go ahead and launch the results reporter when we're done. Okay, so let me pause the recording at this time. Okay, so let's see what's going on here. Let me adjust the width or the height of this results viewer. And I'm going to sort by profile name. And you can see here the layer 1 rates. Now this is only going to run for 10 seconds. Remember, we use a 10-second duration. So we see this at about 0.1% and the other one at 99.9%, I think it was. So once these iteration results are saved, we should see the result reporter launching. Here we go. And let's see if we can see what happened here. So this is the test configuration. And when we open up these databases here, we'll see each trial and each frame size and each load iteration. So let's go ahead and look at this one. So we see that we configured the intended load was 99.9% on these two stream blocks and 0.01% on these two stream blocks. We can see that these passed and these failed. So what will happen in the next iteration is that this will go down by the step, which is we did 1%. So this will be go down to 98.9%. These, on the other hand, will go up by 0.02%. And this will be, we'll see this go up to 0.03. So let's see what happened there. And let's see, we came out with 0.03, and this did not change, okay? And I think that's because of the way I configured it. But the key here is that we see that we have configured an asymmetric throughput rate test, right, where you have a 2544 test, but they're running at different rates. And that is the key of what we're trying to accomplish. All right. And again, what we did was use asymmetric throughput, asymmetric performance test, and we created different load profiles. All right. So anyway, I hope that made some sense. And so if you have any other questions after reviewing the video, please contact us at support@spirent.com and we'll help you out